All right, today we're going to go on a little journey. We're going to follow a single lonely data packet to solve one of networking's most common and, let's be honest, most frustrating mysteries. You know that feeling, right? You send a ping, you try to connect to a server, and just nothing. It doesn't fail with an error. It doesn't time out immediately. It just vanishes into thin air. It is one of the most maddening things for anyone who manages a network. But here's the thing. It's not magic. There's a logical reason for everything. So using material from a Cisco networking module as our guide, we're going to become detectives. We're going to follow that packet, step by step, see how a router thinks, and figure out exactly how to find it when it gets lost. So let's set the scene for our mystery. We have a data packet sitting on PC1. Its mission, should it choose to accept it, is to get all the way over to PC3. The catch? PC3 is on a totally different network. To get there, it's got to hop through a few routers, and each one of those routers has to make a split-second decision. You know, you can think of a router as a super efficient traffic cop standing at a crazy busy intersection. It doesn't have a magical built-in GPS for the entire internet. Instead, it relies on a roadmap, its routing table, to know where to send every single car, or in our case, every single packet. And for every packet that comes its way, the router goes through this lightning-fast loop. It gets the frame, rips it open to see the destination IP address, glances at its roadmap, the routing table, to find the best path, wraps the packet in a new frame, and boots it out the door to the next stop. This happens over and over and over again at every router along the journey. And that map is the routing table. It's the absolute heart of this whole process. It's a precise set of directions. And the accuracy of that map, well, it's everything. If the map is wrong, your packet is going to end up in the wrong city, or worse, drive right off a cliff. So, what's really cool is how the router uses this map. It's got a pecking order. First, it always looks for the most specific direction possible. That's our static route. Think of it like looking for an exact street address. Only if it can't find that specific address does it look for the default route, which is kind of like a giant sign that just says, main highway, everywhere else, go this way. But this is where the mystery begins. What happens when the map is incomplete? What if the router looks for directions to our destination and just finds a blank spot? This is where our packet's journey hits a dead end. So, the packet arrives. The router pulls out the destination IP address and starts flipping through its routing table looking for a matching entry. And nothing. There's no specific route for that network. Okay, no problem. It checks for the default route, the route of last resort. Also not there. The router has absolutely no idea where to send this thing. So what does it do? The only thing it can do. It discards the packet. It just drops it. And poof. That's the moment our packet vanishes without a trace. But it doesn't just die in silence. A properly configured router will actually do you a favor. It sends a little postcard back to the sender, an ICMP message that basically says, hey, you know that packet you sent? Yeah, I had no idea where to send it. This is your first massive clue. That destination host unreachable error is the router screaming at you that its map is broken. So why do these maps get broken? Well, sure, hardware can fail. But honestly, a huge number of these problems come down to us. Human error, a typo in an IP address, forgetting to add a route in the first place. And because these routes are static, they don't automatically update when the network changes, which can create these bizarre black holes where traffic just disappears. Okay, so when that packet vanishes, it's time to put on your detective hat. It's up to you to investigate the crime scene, and to do that, you need the right set of tools. And here is your core toolkit. Ping is your simple yes/no question. Can I even talk to you? Traceroute is your GPS, showing you every single hop the packet takes, or where it stops. Show IP interface brief is just checking that the lights are on and the cables are plugged in. But the real hero, the star of the show, is show IP route. This is the command that lets you look directly at the router's map and see what it sees. All right, theory's great, but let's put these tools to work. We're back to our case. PC1 can't reach PC3. We've done some initial digging, and all signs point to the router in the middle, R2, as our prime suspect. So we hop on R2 and we start the investigation. A ping from R2 to PC3 fails. Okay, we run a trace route. It dies right here at R2. That pretty much confirms it. The problem is on this device. So we pull out our number one tool, show IP route. We're going to look at that map, and that's when we find the smoking gun. We look in the routing table, and there it is. The router thinks it knows how to get to the 172.16.3.0 network. But look at the directions. It says to send the packet to 192.168.1.1. That's a completely wrong turn. It's sending our poor packet off in totally the wrong direction. And the fix is just as logical as finding the problem. First, you tell the router, hey, you know that bad direction? Forget it. You've removed the incorrect route. Then you add the correct one, pointing it to the right next hop address, 172.16.2.1. Simple as that. We've just corrected the map. So you see, once you understand this flow, how the packet travels, how the router thinks, and which tools to use, that frustrating mystery suddenly becomes a very solvable puzzle. At the end of the day, troubleshooting is not about guessing. It's a methodical process. You check the physical path, you check the logical path, and most importantly, you check the map. Show IP route is your best friend. By following those steps, you can always find the break in the chain. But let me leave you with this final thought. What if you do all that? You check the routing table, the entry is perfect. The next hop IP is correct. You check the interfaces, they're all up and running, but the ping still fails. What else could be wrong? What do you check when the basics, when the map itself looks perfect, but you're still lost? Well, that's where the real detective work begins.